Yes, my dear children, before going to start the sums in the exercise 5.1, let us recall the concept. This is the main concept. Based on this concept, the entire exercise problems were given. F of x is function, f of x is said to be continuous at x is equal to a at a particular point. Most of the cases we discuss at a particular point. Okay. Then by implies as x tends to a, limit f of x is equal to f of a. If this condition is satisfied, then the given function is said to be continuous at that given point. Okay. Please remember this point, my dear children. Now come to the question number 1. Yes, good afternoon, Preetika. Good afternoon, my dear Stains Johnson. Why didn't you attend on Saturday? Why didn't you attend the IIT coaching, Preetika? Stains Johnson. Why didn't you attend for the classes on Saturday? Okay, my dear Stains Johnson. What about Preetika? What about you? Have you not attended for any class, my dear Stains Johnson, on Saturday? Have you not attended? Okay. You also not attended for any class, Preetika, on Saturday? Have you not attended for any class on Saturday? Have you not attended for any class? Okay. So hereafter, don't you attend for maths class for IIT coaching on Saturdays? Don't you attend for IIT mathematics classes on Saturdays hereafter, Preetika?
Sir?
Will you not attend for the upcoming IIT coaching classes on Saturdays?
No,
You won't?
no, sir. Maths I'm not attending, sir. Only chemistry, physics, and biology I'm attending, sir.
Okay. So, okay, ma. Yes. Now come to this point. This is the important point. Now come to the question number 1. Question number 1. Prove that the function f of x is equal to 5x minus 3. 5x minus 3 is continuous at x is equal to 0, at x is equal to minus 3, and x is equal to 5. We have to verify whether this function is a continuous function or not at these 3 different points. So we check one by one. We check the continuity of this function at every point separately. Now, to verify or to check the continuity of a given function, we have to find this value as x tends to a, limit of f of x, and we find f of a separately. If the both values are same, if the two values are same, only in that case we say that it is a continuous function, otherwise it is not continuous. So prove that. It is asked here, prove that. So to show that First, we are taking this point at x is equal to 0. We have to show that given function is a continuous function at x is equal to 0. So, what is the value of a here? What is the point here? 0. So, let us find limit of this function as x tends to 0. Limit f of x. That is equal to, as x tends to 0, limit, what is f of x here? 5x minus 3. Because f of x is equal to 5x minus 3. So previously I told you there are different methods are there to find limit of a function at a given point. First and foremost method is the substitution method. First and foremost method is substitution method. Means directly we substitute the given point in the given function. That is the simplest and first and foremost method. So 5 into 0 minus 3 by substitution method. In this substitution method, you need not to recollect any formula. You need not to recapture any formula. Directly substitute. If you have a skill, if you are strong in substituting the values in a given function, then this part is easy. Okay. Then what will you get here? 0 minus 3, that is equal to minus 3. So we found here limit of this function as x tends to 0. Now f of 0. What is meant by f of 0? You have to find the value of f of x, value of f of x at x is equal to 0. Means here also we have to substitute x is equal to 0. We have to replace x by 0. So 5 into 0 minus 3. So 0 minus 3 minus 3. So if you find as x tends to 0, limit of f of x is equal to minus 3. F of 0 is also minus 3. Both values are same. Therefore, as x tends to 0, limit f of x is equal to f of 0. Therefore, f is continuous at x is equal to 0. So, we have proved that given function is continuous at x is equal to 0. Similarly, we show that given function is continuous at x is equal to minus 3 and f of x is continuous at x is equal to 5. Will you do these two parts? Will you show these two parts at x is equal to minus 3 and at x is equal to 5, given function f is continuous?
Yes,
Will
sir.
you do the same procedure, only numerical values of x were changed. Same steps. Okay. So I am not doing these two parts. Okay. Please try the remaining two parts, and if you have any doubts, ask your doubts and get your doubts clarified. Is it clear, my children? Is it clear?
Yes, sir.
Yes, sir.
Message me. Yes, message me. Yes, sir.
Yes, sir.
Yes, sir. Like this, message me in the chat box, or just simply tell me. At least tell me or message me in the chat box so that I can understand that you got the point. Okay, my dear children, have you taken the screenshot of this page number 1? Have you taken the screenshot of this page number 1? Take it fast. Anyhow, I will send you the classwork notes, but in the safe side, in the safe side, it will be in your system until you receive the PDF of classwork notes from my side. Okay. Have you taken the screenshot? Welcome to the question number 2. Question number 2. Examine the continuity of the function f of x is equal to 2x square minus 1. Given f of x, given function is f of x, that is equal to x square minus 1, and the given point is x is equal to 3. Given point is x is equal to 3. At this point, we have to examine, we have to verify, we have to check the continuity of this function. Means whether it is a continuous function or not at this particular point. We follow the same procedure as we have followed for the first question. To examine the continuity of f of x at x is equal to 3. At x is equal to 3. What is f of x here? 2x square minus 1. What should we find? First of all, what should we find as x tends to 3? As x tends to 3, limit of f of x. As x tends to 3, limit of f of x. Or limit f of x. That is equal to, as x tends to 3, limit f of x is here 2x square minus 1. Because f of x is equal to 2x square minus 1. So this is a polynomial function. We can use a substitution method as we followed for the previous question. We follow the same procedure. 2 into 3 whole square minus 1. By substitution method. This is one of the methods. This is the one of the methods in finding limit of a function at the given point by substitution method or by direct substitution method. We can say by direct substitution method. By direct substitution method. Then what will you get here? 2 into 9 minus 1, that is 18 minus 1, that is equal to 17. We got here, we found here limit of this function at x is equal to 3. As x is approaching to 3, we found limit of the function. Now let us find f of 3. F of 3 is nothing but substituting the value of x in the given function. So 2 into 3 square, 2 into 3 square minus 1, 2 into 9 minus 1, that is equal to 7. If you compare these two values, they are equal. Are they equal or not? Are they equal or not?
Yes, sir.
They are equal. Therefore, as x tends to 3, limit f of x is equal to f of 3. Therefore, f is continuous at x is equal to 3. Hence verified, or you can write a conclusion, hence examined, or hence verified. Okay, hence verified. Okay, my children, is this clear? Is this question number 2 clear?
Yes, sir.
Yes. Message me in the chat box at least. Message me. If you have understood, message me. Yes, sir. Understood, sir.
Yes, sir.
Clear, sir. Otherwise, message me. Repeat it once again, sir. Please explain me one more time, sir. Like this, message me. And now take the screenshot of this page number 2. Now take the screenshot of this page number 2. Take it fast. In the meantime, if any doubt is there, message me in the chat box. Okay. Taken the screenshot? Have you taken?
Yes, sir.
Yes, come to the next question. See the question number 3. Examine the following functions for continuity. See the question number 3, my children. Is there any difference between 1, 2 questions and this third question? Have you observed any point? Any difference? Is there any difference between these?
So they have not given which point we need to find the continuity, sir.
Tell me the difference.
So it's not given like in which position, which point we need to find the continuity, sir.
Yes, very good. In this question, they have not given a particular point. They have not given a particular point, as they have given for the first 2 questions. They have given particular point at x is equal to 3, at x is equal to -5, at x is equal to 1. In this way, they have given particular points. But whereas in this case, here, point is not given. Only functions are given. Only functions are given. In this case, see here, given function, given f of x is equal to x minus 5. Here, particular point is not mentioned. In this case, we have to take x is equal to a, or x is equal to small letter c, x is equal to small letter a, some real number. We assume that x is equal to a. So we are assuming some value for x, that is small letter a. Numerically, it is not given. That is why we have taken like this. Now, we got particular point. What is the particular point here? Tell me. What is the particular point here?
X equal to A, sir.
That only. X is equal to A only. We assumed here point A. So, indirectly we got point A. Now we find to examine. To examine the continuity of f of x at x is equal to a. So first of all, we find limit as x tends to a, limit f of x, that is equal to, as x tends to a, limit, what is the function here? X minus 5, because f of x is equal to x minus 5. We replace the f of x by x minus 5. So we follow direct substitution method. Previously also I told you many times, when you are finding limit of a function at a given point, first and foremost method is a substitution, direct substitution method. So in the place of x, we write a minus 5 by direct substitution method. Previously also I told the different methods by substitution method, by factorization method. Yes or no? In the previous class I told you methods of finding limits.
Yes, sir.
Yes, sir.
Rationalization method. Okay. Standard limits method. Do you remember that methods? We
Yes, sir.
follow
Yes, sir.
that methods according to the question. So we got a minus 2. That's all. This is only the limit of this function. A minus 5 is the limit of this function as extends to a. Now let us find f of a. F of a is in the given function directly substitute a. If you observe limit of this function as extends to a is equal to f of a. Therefore, as extends to a, limit f of x is equal to f of a. That's all. Therefore, f is where a belongs to R. F is a continuous at x is equal to a, where a is any real number. In all real numbers, at any point of real number, this function is a continuous function. Okay, my children?
Yes, sir.
Now take the screenshot of this page number 3. Page number 3. And if any doubt is there, message me in the chat box. Explain me, sir, or repeat it once again, sir. Have you taken a screenshot?
Yes, sir.
Yes. Now, see the next question. In this Roman number 3, see the next question. B, f of x is equal to 1 by x minus 5. F of x is equal to 1 by x minus 5, comma, x is not equal to 5. X is not equal to 5. Except the value of x is equal to 5, you have to check the continuity of this function. Okay. Same procedure. We follow the same procedure. A should not be equal to 5. A be any real number. We can take the values for x, any real number, except 5, because x is not equal to 5. That is why we mentioned here a belongs to R and a is not equal to 5. So here also we follow the same procedure, nothing else. Nothing else. So continuity as extends to a, limit f of x, that is 1 by x minus 5, because f of x is equal to x minus 5. Then how do you find limit of this function? What is the limit of this function? Tell me, what is the limit of this function? One by a minus 5 by direct substitution method. We found here limit of this function as extends to a. Now f of a is equal to 1 by a minus 5, comma, a is not equal to 5. We have taken a is not equal to 5, but any real number. So if you observe, these two values are same. Therefore, as x tends to a, limit f of x is equal to f of a. Set of all x belongs to R minus a singleton set 5. Hence verified. Okay, my children. Now take the screenshot of this page number 4. If any doubt is there, if any confusion is there, message me in the chat box. Otherwise, take the screenshot of this page number 4. Take it fast. Completed taking the screenshot.
Yes, sir.
Okay. Now let us go to the next question. Yes. Next question. See the question number C. F of x is equal to x square minus 25 by x plus 5. X square minus 25 by x plus 5, comma, x is not equal to minus 5. X is not equal to minus 5. See this question, my children. As x is not equal to minus 5, let us write this function, let us rewrite x square minus 5 square by x plus 5. X is not equal to minus 5. This can be written as x plus 5 into x minus 5 by x plus 5, comma, x is not equal to minus 5. Since x is not equal to minus 5, means denominator is not equal to 0. Denominator is not a 0 number, non-zero number. So we strike out x plus 5, x plus 5. So indirectly f of x is x minus 5 only, not this function. Indirectly f of x value is x minus 5 only. Okay. Now we assume that a belongs to R. Let x is equal to a. That is a real number. That is a real number. Now to examine the continuity of f of x, that x is equal to a. Hereafter we follow the same steps. As x tends to a, limit f of x, that is equal to, as x tends to a, limit f of x means x minus 5. Don't take this function x square minus 25 by x plus 5. Don't take that function. This function only. You have to consider finally this function only. So that is equal to a minus 5 by direct substitution. By direct substitution method, we got the limit of this function as x tends to a is a minus 5. Now f of a, f of a is equal to a minus 5 only. Both values are same. Therefore, as x tends to a, limit f of a, f of x is equal to f of a. Therefore, f is continuous. Simply we can write f is continuous in its domain. F is continuous in its domain. Okay, my children. Now take the screenshot of this page number 5. Take the screenshot of this page number 5. Have you taken a screenshot? Have you taken a screenshot, my children?
Yes, sir.
Now come to the question number D. F of x is equal to modulus of x minus 5. F of x is equal to modulus of x minus 5. Now let us rewrite this given function. It is a modulus function. So in this, yes, what, my dear Yashwantram? What, my dear Yashwantram? Do you want to say something? Yashwantram,
Sir?
do you want to say something?
No, sir.
Okay. So here f of x is given as modulus of x minus 5. Within the modulus symbol, what is the given function here?
X minus 5.
So x minus 5 is equal to 0. Take this function is equal to 0. Write this equation. From this equation, what is the value of x? X is equal to 5. Yes or no? We found the value of x. So on the number line, on this number line, so this function will be divided into two parts. At x is equal to 5. At x is equal to 5. At x is equal to 5. The function is divided into two different categories. So let us write f of x is equal to x minus 5 if x is greater than 5. If x is greater than 5. What will you get? Suppose if you take 10 minus 5, what will you get here? 5. If you take 6 minus 5, it is a positive number. So f of x is taken as f of x is equal to x only. Mod x is equal to x. Since mod x is equal to x, if x is greater than or equal to 0, or f of x is mod x is equal to minus x, if x is less than 0. So Next one. If we take any negative number, 4, if you take 4 minus x, what will you get here? Negative number. If you take 3 minus x, you get a negative number. So we take minus of x minus 5. In the place of x, we are writing x minus 5. Minus of x minus 5. If x is less than 5. Less than 5. In the place of 0, we wrote 5 because at this point 5, in two intervals, this is one interval and this is another interval. Less than 5 is one interval and greater than 5 is another interval. So in these two intervals, f is defined. This implies f of x is equal to x minus 5 if x is greater than or equal to 5, multiplied by minus 5, what we get 5 minus x if x is less than 5. So in these two intervals, we have to verify whether it is a continuous function or not. Okay. Here we use the modulus function definition. Okay. Now take the screenshot of this page number 6. We have not started verifying the continuity of this function. We have not started that part. Just we have rewritten. We wrote the given function as f of x is equal to x minus 5 if x is greater than 5 and f of x is equal to 5 minus x if x is less than 5. So here in this interval we define f of x if x is less than 5 minus x, and in this interval f of x is equal to x minus 5. In both intervals we verify the continuity of this function. Okay, my children. Now take the screenshot of this page number 6.
Taken, sir.
Have taken?
Yes, sir.
Yes. Now come to the point. So at this point, it is enough. At this point, we verify the continuity of this function. At this particular point, because at this point, this function is defined in two ways. That is, f of x is equal to 5 minus x. Here, f of x is equal to x minus 5. So in this case, we find left hand limit and right hand limit. We find here left hand limit and right hand limit. In this case, we find left hand limit and right hand limit because this function is defined at x is equal to 5 in different ways. At the particular point, left side is defined as x minus 5 minus x, and right side x minus 5. So in this case, we find left hand limit and right hand limit. So as extends to 5 minus f of x. This notation denotes left hand limit of f of x as extends to 5 from left. Okay, from left it is approaching to 5. x values are approaching to 5 from left. It is denoting the meaning. Okay. So as x tends to 5, limit left side, how the function is defined? 5 minus x. 5 minus x. Because f of x is equal to 5 minus x if x is less than 5. If x is less than 5, it is defined. Now, find limit of this function, direct substitution method. 5 minus 5, that is equal to 0. By direct substitution method, therefore, as x tends to 5 minus limit f of x left hand limit of this function at x is equal to 5 is 0. Now let us find right hand limit of this function at x is equal to 5. So we denote it by this symbol as x tends to 5 plus limit f of x is equal to, as x tends to 5, no need to here 5 plus. Don't read it as 5 to the power of plus. Don't read it as 5 to the power of plus. 5 plus. Simply we read it as 5 plus. Limit 5 plus means right side of this 5. At this point 5, right side f is defined as x minus 5. X minus 5. So, because f of x is equal to x minus 5 if x is greater than 5. Okay. Now, how do you find such limit of this function? Direct substitution method. 5 minus 5 by direct substitution method. That is equal to 0. Therefore, as x tends to 5 plus limit f of x is equal to 0. Here left hand limit and right hand limit of this function at x is equal to 5, both are equal. Okay, therefore 5 minus limit f of x is equal to, as x tends to 5 plus limit f of x is equal to 0. After that, we have to find f of 0. F of 5. At this point, f of 5. Let us find f of 5 value. That value also should be equal to 0. All the three values should be 0. I told you at that concept time when I explained the concepts of this exercise, continuity of a function, we have to find left hand limit, right hand limit of the function at that point, and value of the function at that particular point. Okay, now up to here, note it down. After that, we find value of the function at x is equal to 5. Take the screenshot of this page number 7. Take the screenshot of this page number 7 first. Have you taken the screenshot?
Yes, sir.
Now let us find f of 5. F of 5. Now f of 5. 5 minus 5 because f of x is equal to x minus 5 if x is greater than or equal to 5. If x value is 5 or if x is greater than 5, f of x is equal to x minus 5 only. So in this function I substituted x is equal to 5. So we got here 0. Therefore, as x tends to 5 minus limit f of x is equal to, as x tends to 5 plus limit f of x is equal to f of 5. In all these three cases, we got the same value. Therefore, we say that, therefore, f is continuous at x is equal to 5. So, for all real numbers, we have just verified at x is equal to 5, but left side it is a polynomial function, right side of 5 is also a polynomial function. Therefore, for all real numbers, it is a continuous function. Therefore, f is continuous f is continuous for every real number. Now take a screenshot. Of this page number 8, my children. Take it fast and now the time is
Taken, sir.
Taken, sir.
yes. Is it clear? We have found left side limit, right side limit, and f of that particular value. Both all the three values are equal. That is why we say that f is continuous at that particular point. But on the whole, for every real number, it is continuous because left side it is a polynomial function. Previously, we have discussed every polynomial function is continuous at every real number. For every real number. Just to revise that points. That is why we concluded this one. F is continuous for every real number. Okay, my children. Now the time is 2 past 18 minutes. Now you can take rest. Take care of your health, my children.
Thank you, sir.
Stay at home.
Thank you, sir.
Stay safe.
Thank you, sir.
Thank you.
Sanitize your hands frequently. Maintain social distance of 2 meters away from others and do your duty sincerely and seriously. And thank you all, my dear children. Thank you all.
Thank you, sir.
Thank you, sir.
Thank you, Joseph. Thank you, Grayson. Thank you, Ayush. Thank you, my dear Kevin Paul.
Sir,
Yes, my dear Ayush.
sir, actually, I have a doubt on exercise 1.2, question number 1. Sir, so can you please clear that?
Not now. After 6 o'clock today, after 6 o'clock, call me. I will clear your doubt.
Sir, in 1.2, I have so much of doubts there, so I have not completed 1.2 yet.
Uh,
That's why I was too delayed.
I have posted videos of that classes. Have you watched
Sir,
the
but,
videos? Have you
sir,
watched
but,
the videos?
yes, sir. Sir, I have watched the videos, but I was unable to understand, sir.
Not only one time. Not only one time you can't understand. Repeatedly, you have to watch that video repeatedly. Then you catch that point. You catch that technique. What is the technique in the questions? What is the technique in the solutions? Okay. Otherwise, today evening, call me. I will clarify your doubts.
Okay, sir. I will watching, sir. If I still get doubts, so I will call you at
Ah,
6 o'clock.
yes. First watch the videos. That is why I'm posting the videos, not for time pass. Whatever the concepts I explained, the same points. If you listen the same points, then you recollect the points. Then you recollect the points. Then you can revise the points thoroughly. That is why I posted the videos of every class.
Okay, sir. Thank
Okay.
you.
After watching the videos, again, if you have any doubts, then call me and get your doubts clarified.
Okay, sir.
But I will ask you questions on that concepts. What is a
Okay,
function?
sir.
What is one function? What is onto function? Okay. You should be strong in definitions. Without knowing the definitions, without learning the definitions, you can't understand anything.
Okay, sir.
Okay. Please carry on.